Number 27. A child on a sled with a combined mass of 50 kilograms slide down a frictionless slope. If the sled starts from rest and has a speed of 3 meters per second at the bottom, what is the height of the hill? So we're looking for height, which we don't know. We have a mass of 50 kilograms, and we have a velocity of 3 meters per second. Now hold on, before we get started, there's one piece of information that will prove to be critical, and that is if the sled starts from rest and has a speed of 3 meters per second. So that phrase, starts from rest, is imperative because that tells us that the initial velocity is 0 meters per second. Alright, now let's get started solving the problem because we have all the information we need. So we'll start off by drawing a diagram of a hill, a child and a sled. So here's a child going in a sled. Don't know what a sled looks like, but here's a sled. So it's going with the velocity of v. And there we go. Now let's get started. So we can use the conservation of energy, which in this case would be the following equation. So the initial kinetic energy, we can just write this out. It includes the initial velocity. So it's 0, because we said here that the initial velocity is 0. The initial gravitational potential energy would stay, because there's no 0 here. And the final kinetic energy would stay, because we are given a speed here. And the final potential energy would stay as well. So now we're going to isolate, I'm just going to isolate V, but we're finding H. This is what we're looking for. So let's start off. Mg, and before I get started actually, there are 3 m's here. Every term has a constant m. We can cancel each one of these. So now we're just left with this. Now I'm going to keep going. It's GH0 minus GH is equal to 1/2 V squared. You can factor a G out of there and multiply a 2, because there's a 1/2 here. You can multiply a 2 on the other side algebraically. That's V squared. And now I think we should be able to find the height. So 2 times 9.8 meters per second squared, because that is the gravity constant, the vector, and h0 minus h is unbeknownst to us, and v squared is 3.00 meters per second squared. So we know that 3 squared is 9, so h0 minus h is equal to 9 divided by 19.6, which comes out to meters. If you do that, it's going to be meters squared per second squared, meters per second squared. So this is canceled, and this is canceled. So we end up with this as our height, which can be approximated at 0.459 meters.